Okay, concave up and concave down is a concept that we need to understand from a couple of different perspectives. So we're going to start with a visual perspective. So if you look at a graph and it is completely flat, so something like this or this or this. What I would say with these is that they are completely flat and there is no concavity to them. Okay? Now, there are two ways to have concavity. You can be concave up or you can be concave down. And the easiest way to see this from a visual perspective is to show you that these two are concave up and these two graphs are concave down. There's a couple of ways to remember this. So I always like to think of up is the letter U. So if it opens up like it would hold water, that is concave up. If you look at this one and you think of the word down, it ends in an N. And do you see how N goes down? Do you see how these open down and they're kind of caving down? The cave is down. That is concave down. Another way to think about it is if the shape would kind of hold water in it, if it would hold that water somehow, that is concave up. But if it's shaped in a way that the water would just rush off of it, that is concave down. Or you can just remember the letters U or N. So if you just look at these pictures, you can see visually where it is concave up and where it is concave down. Now, just like with increasing, decreasing, and positive, negative, we look at the y's to see is it concave up or concave down. But what are we going to report? We are going to report the x values in interval notation when something is concave up versus concave down. So let's give this a try. This is a pretty crazy looking question. And so the first thing I'm going to do is start putting in some numbers because this is just a lot of things going on. And we need to decide in each section, is it concave up or concave down? And this can get a little bit tricky. Okay, so let's just move left to right and let's look piece by piece. So let's look at this piece right here. Is that piece concave up or concave down? What do you think that one is? So I think it looks more like an N than a U. So I'm going to say that this piece is concave down. And if you look at all of the colored in line here, this piece goes all the way back this way to negative infinity. And then it does this thing called an asymptote here at -6. So remember, we're going to think left to right, smallest to biggest x. So what is the smallest x as we go this way? Well, that is concave down. So we're going to put it in this place where it says concave down. And it is from negative infinity to -6. This thing is concave down. Now, because there's an asymptote here, we have to break. There is nothing happening at 6. So remember, if we have an asymptote or a hole, we have to break up that interval notation at that spot. All right, so now if we look at this next bit here, right here in this part, would you say that this is concave up or concave down? Well, again, to me, this bit looks like an N, so this looks like it's concave down. But then if I keep going, this bit looks like it's concave up to me. And so the question always becomes, well, where does it switch? And that can get a little bit tricky from pictures if it's not on an absolute spot. So I think it looks like it switches right here, roughly, right? So we're going to call that an x value of -2.5 or -2.5 is where that x value is. Yes, it's probably not quite that, but we're going to call it that. It's roughly there. And if you see, before this, the graph is concave down, and then sort of after this is the graph is concave up. So we have a special name for a spot like this. This is called a point of inflection. Any point An XY point where the graph goes from concave up to down or down to up is called a point of inflection. And it's kind of an interesting point when we get to applications and stuff like this. But okay, so let's go back to what are the X values. So this looks like we're going from -6, and since it's an asymptote, not included, and we're concave down until we've decided that it switches here at that -2.5. So we're still concave down from -6 all the way to -2.5. And just like with increasing, decreasing, we're not going to include the endpoints. I'm not going to like freak out on you if you do, but we're not going to include those endpoints because technically at that spot, is it both? Is it neither? What is going on? So we're just not going to include it. Now, let's talk about the concave up bit. At -2.5x, it looks like we end up concave up, and again, since we hit an asymptote here, I feel like this whole thing is concave up from the x of -2.5 all the way to the x of 2. So where is this graph first concave up? From -2.5x all the way to the x value of 2. So all of this shape is concave up, but remember, we're reporting the x's. So we report from -2.5 all the way to +2. Let's pop over to the other side. Let's look at this bit from -2, where that asymptote is, to about here, this spot right here, right at x equals 4. It looks like it switches to me. So this first bit looks concave down, and the second bit looks concave up to me. So I'm going to say we are concave down from x is 2 all the way to x is 4. So this bit right here looks concave down to me. So we'll list that here. From 2 to 4, we're concave down. Remember, this part's up and this part's down. And then this last bit is a little bit interesting. So from 4 to 6, and then from 6 to 8, it's all concave up. But what about this spot right here? Is that a point of inflection? Does it switch from concave up to concave down at that spot? No, it doesn't. So we do not need to break here. So we're going to go all the way from x is 4 to all the way to positive infinity, that this graph is concave up. Even though it kind of like peaks at that spot, it's still up on both sides of it. So we're going to call that one individual spot concave up as well. So 4 to infinity is where this graph is concave up. So graphically speaking, I hope you can just remember U shapes are concave up, N shapes are concave down, and we always report the x's.